We're coming down to the final steps here, final examples. Putting a lot of these ideas together. So first of all, I've got a division here, but on the top I first have to expand the top. So that's going to be equal to x to the 3, y to the 6, plus 5x cubed, y to the 6. You might recognize those as like terms right away. 6x to the 4, y to the 7, all over negative 3x cubed, y to the 5. And so what we're going to do is put these like terms together, 6x cubed, y to the 6. But a lot of you guys probably didn't see that. So let's take this in two shots like you probably would have done. You would have said x to the 3, y to the 6 divided by negative 3x to the 3, y to the 5. So you divide 1 divided by negative 3 is negative 1/3. X cubed divided by x cubed, they disappear. Y to the 6 divided by y to the 5 is simply y. Plus, but be careful because I'm dividing negative 3x cubed y, so you got to divide 5 and negative 3, so that's negative 5/3. X to the 3, again they disappear. Y to the 6, y to the 5 is going to be y. And negative 6x to the 4, y to the 7 divided by negative 3x cubed, blah, blah, blah. Okay, and you divide 6 divided by negative 3, negative 6 divided by negative 3 is positive 2. X to the 4 divided by x to the 3 is just x, and y squared. And as I said before, these guys are like terms, so hopefully you're recognizing this at that point. Negative 1/3 and negative 5/3 is negative 6/3, which is simply negative 2. And just because I'm running out of room, I'm going to put my answer right here. So that's going to be negative 2y and positive 2xy squared. Answer for number 6. Moving to number 8. And I'm sneaking into its territory here. Hopefully I won't be running out of room. Multiplying this times all three terms. So that's going to give me 2m to the 4, n to the 5. Then 6, right? 2 times 3. m to the 3, n to the 6. And then minus, you're multiplying this times the negative 6, right? The third term. 12, m n to the 5. Next part, don't forget you're multiplying negative 2 times both of those terms. So that's going to be negative 6m cubed n to the 6 and negative 2m n to the 5. Now I think I've got some like terms along the way here. Hopefully I do. 2m to the 4 n to the 5 is going to be just left that way. It doesn't have a like term to it. 6m cubed n to the 6. Oh, I got negative 6m cubed n to the 6. So those guys are going to disappear, right? They're going to negate each other. And negative 12 and negative 2 is going to be negative 14m n to the 5. Okay, it did fit. You'll do your work neater. I'm just trying to put this in the space that I have available. Okay, now some fractions. Now, you don't want to panic about fractions, but the main rule is to remember you need like terms. Common denominators. But it's very similar to the idea of like terms. So I got 5, 4, and a 2. I need to find the least common denominator. Same thing as LCM. The smallest number that all three of these guys divides into evenly. In this case, 20. The easiest way of doing that is try doubling or tripling or quadrupling the biggest number. So this is going to be over 20. That's going to be over 20. That's going to be over 20. And you have to ask yourself, what do you multiply by so that that's going to go into 20? 5 times 4. So I would multiply the top and bottom of this by 4. So that's going to be 32x. Then multiply this 4 times 5. So you multiply 5 times each of those. Now this is a binomial, so don't forget to multiply both of them. 10x minus 30. And this one's going to be multiplying 2 goes into 20 10 times, so you're going to multiply top and bottom by 10. So 20 on the bottom, 30 on the top. When you put this together, you just keep that denominator of 20, and you're going to get a whole mess on top here. 32x plus 10x minus 30 plus 30, all on the top. Well, the cool thing here is the negative 30 and the plus 30 cancel each other out, so it's simply going to be 42x over 20, right? These guys, negative 30, positive 30, they're gone. Divide through by 2 to reduce that fraction. Doesn't reduce any further, leave it as it is. Okay, this one is the real challenge. You got to know which rule to use when, and you got the negative exponents to bug you. But we'll take one term at a time and see what happens. 1 over x plus 4 to the negative 1. Now, this is a negative exponent. We use the happy sad rule. The negative exponent says move it up on top. So that's going to be x plus 4 on the top of a fraction. To the exponent 1, I don't even have to write it. If you want, you can pretend it's there. That's the top of a fraction. You can put that if you like. Next, negative 3 to the negative 2. Now, be careful. This is the minus on the front of the number. Okay, that's that minus floating there. But the 3 to the negative 2 simply says 3 to the positive 2 in the bottom. What do you leave on the top? You got to put something there. Let's put a 1. Next term, the x on the top, 2 to the negative 2 on the bottom. Well, x stays on the top. 2 to the negative 2 goes on the top as 2 to the positive 2. All right? 2 squared. Well, I don't like to look at that. I want to put the 2 squared in front. So that's going to be 2 squared x. Bottom of the fraction, just like before, you want to put something there, put a 1, but you don't need to. And the next fraction, I got 3 to the negative 3 times 3x. Now this is one term. Terms are glued together with multiplication. So the 3x is going to go on the top of that fraction, and the 3 to the negative 3 is going to become 3 to the positive 3 in the bottom. Looking like a mess, but let's see what we have when we clean up these a little bit. This is simply x plus 4. This is minus 1 over 9. This is 4x. And this one, well, you got 3 and you got 3 cubed. Now 3 cubed is not 9, it's 27. So 3 over 27, you can reduce that to 1 over 9. So that's going to be equal to 1x over 9. Which, hey, those are like terms, right? Those are two like terms. And so, let's see what I can do with this. X, that's 5x. Plus 4 and negative 1/9 plus x over 9. I should have got a common denominator for the whole thing. Okay? So that's going to be 9x plus 36 minus 1 plus 36x plus x all over 9. Right? Got everything over 9. So 9x plus 36x plus x is going to be 45, 46x. I think I made a mistake in this question. 36 minus 1 is 35 over 9, because I don't remember getting these answers when I did my answer sheet. Probably wrote the question wrong, which is typically what I do. Okay. Oh yeah, I forgot the x here. Okay, that makes life a lot easier, because when you get down to this one, that's negative 1x, and that's x. And the negative x and the plus x cancel out. And so that just leaves you with 45x, right? 9x plus 36x. 45x plus 36 over 9. Hey, look, the 9 goes into both of them. So that's going to leave me with, let's get that out of the way, 5x plus 4. And I'm going to run out of room here, so I'll write it here. Sorry for the mess. 5x plus 4. You divide them both by 9. That's your final answer. Yeah, that's what I got. Okay, so sorry for that mess, but that's your answer. Thank you very much.